Hello students, welcome back. Let's go to the second most important problem. Second most important problem is, to me, is a kind of tie between the regression problem 1314Ds and discrete probability distribution problem number 3. Well, let's do number 3 first. And let's go to the problem set here in PDF file. It looks like this. I gave you the cumulative distribution function, capital F of x, written in piecewise defined function format. F of x, cumulative probability is 0 for x is less than -1.5, the first class interval. And the cumulative probability is 0.3 for the next class interval, 0.5 for the third class interval, and probability 1 for the last class interval. And the breaking point is -1.5, that's where first and second interval breaks. And then at 2.5, the second and third interval break. And finally, at 4.5, third and fourth intervals break. So we have 1, 2, 3 breaking points. You can read all those from this piecewise defined expression. Here in this notebook, I used tabular expression. First class interval less than -1.5. Second, -1.5 to 2.5. Third, 2.5 to 4.5, and finally fourth, greater than or equal to 4.5. Again, the same deal. We have the breaking point here. First, we have second breaking point here, and a third breaking point there. And that'll give you the probability mass function. Here we go. First breaking point, -1.5, and I color-coded in blue. Second breaking point, 2.5, I color-coded in red. And third breaking point, 4.5, I coded in blue, red, green like this. -1.5, 2.5, 4.5, otherwise. Okay, hard part is done. The interval part now became points. Now let's find out the probability mass. These are cumulative probabilities obtained by repeated addition. Now, how do you go back? The inverse of addition is subtraction, so we subtract. -1.5, these two are common, right? We subtract. So we get probability mass of 0.3. 2.5 is common in second and third intervals. We subtract. And then we have probability mass. 4.5 is common in third and fourth interval. We subtract. And that gives you the third probability mass, and otherwise 0. And there goes my probability mass function. Now, if I give you the mass function, can you get the cumulative distribution function? Well, I could have written the problem like that as well, so think about how to do this. How to get here to there. Well, -1.5, 2.5, 4.5, those are 3 breaking points. So less than -1.5, between -1.5 and 2.5, and between 2.5 and 4.5, and greater than 4.5. So we have those 4 intervals, 1, 2, 3, 4 intervals. And then for those intervals, we just have accumulation, add up. Add 0.3. Add 0.2, we get that. And add 0.5, that's the end. You should be able to do one way or also the other way around. Here in this particular semester, I wrote CDF to PMF problem, but I could have done backward equally as much. So study both. Now, once you have that mass function, you can find out the expected value variance and the probability standard deviation. I want this mass function. Yeah, the last one here. So how do you get the expected value? You just multiply by payoff and the probability, blue, and the payoff and the probability, red, and payoff and the probability, green, and then add them all up. That's the formula for mu, the mean or the expected value. Use E or mu either way. Now how about the variance? Payoff minus mu squared. We want deviation squared. So negative 1.5 minus 2.3. Calculated earlier. And 2.5 is the next, minus 2.3. 4.5 minus 2.3. And then deviation squared and multiply the probabilities. You're just working with this formula. I have only 3 probability masses, so the computation is relatively simple. If I give you something like 5 probability masses, I guess that's the maximum I can give you in the exams. Even that's too many. Up to 3 or 4. Okay, maybe up to 5, but not more than that. In any case, I'll grade as generously as possible in these kind of problems because these are just computation problems. Finally, the standard deviation, we just take the square root of the variance and that's it. Square root of 6.76, we end up with 2.6. And that's it. We were exceptionally lucky this time to have terminating decimal in square root. Most of the time you're going to get really long square root, so you have to cut, say, 2 decimal digits, 3 decimal digits, whatever. Use your own discretion. Okay, so much for discrete probability distribution problem. And okay, let's stop here.